Alright kids, hopefully this is working. Hold on, I probably should have checked my mic, but I think my mic's working. Let me check to make sure. Shoot. Is my mic working? Yes, my mic is working. Alright, so sorry, I haven't used this in a while. So let's hope this works. I haven't recorded a video in a long time. I already did like half of this video upstairs in my room on my other computer, and well, it didn't work very well. So let's try this. Let's get rid of this. Alright, so the reason we're going to be doing this is because on Monday, those of you that want to take that IB assessment are going to get the opportunity to take that IB placement exam. It's not a big deal. I don't want you to worry about it. Just try to do your best on it. And if you do well, that's great. If you don't do well, that's great too. It's just a small piece of what we're going to use to decide who do we actually recommend for that IB calculus course. We'll talk a little bit more about that on Monday. All right, let's talk about rules of exponents. Let's see if I have my pen up. I think I have my pen up. Okay. So what we're going to talk about, I think you already know this, when we have an exponent raised to an exponent, what we're going to do with those exponents is multiply them. So for example, if I had over here x to the fifth cubed, that's really x to the fifth times x to the fifth. I'm not as good at writing on this as I used to be. I've never been good at writing on this. I'm not going to be honest. I'm not going to lie. That's really equal to x to the 15th, because there's really 15 there. So when you have an exponent raised to an exponent, you simply just multiply the exponents. Now, of course, the base has to be the same. If the base isn't the same, you can't do this. Okay? So what are we going to do now? Ooh, man. If you have an exponent, and this one, as long as the bases are the same, if you have an exponent, some base to some exponent, all you do is add those exponents. And again, you already know this rule. X to the fifth times x cubed is equal to x to the eighth. So when you have an exponent raised to an exponent, we multiply them. When you have an exponent times, you have a variable raised to an exponent times another variable raised to an exponent, you add those exponents. Now, this one, I don't know why it's new. It shouldn't be that new to you. But when you're dividing, what you do with the exponents is simply to subtract them. Again, as long as the bases are the same. So in other words, if I had x to the, let's say 6 divided by x squared, that's really equal to x times x times x times x times x times x. That's 6x's divided by x squared. So what happens is these x cancels and these x cancels, and it leaves me x to the fourth. Really, that, I don't know why these pens are so huge. All right, now what if it was the other way around and you had x squared divided by x to the fourth? Well, again, that's going to be equal to x. This one is equal to x to the 6 minus 2, which is 4. What if I had x to the squared divided by x to the 6? Well, that's x to the 2 minus 6, which is x to the negative 4, which we're going to be dealing with in just a minute. I don't know why I picked 4s. I cannot write 4s with this thing. But if I did this one, wouldn't this be equal to x times x on top all over x, 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 x. These 2's would cancel, these 2's cancel, and it'll leave me 1 over x to the positive 4. Hey, I wrote a 4 good. So the only thing I want you to remember is when you divide, as long as the base is the same, you just subtract the exponents. So I'll show you an example of that. So let's show you an example of all these. So all of this is being squared. So 2 squared is 4. X cubed squared. Again, exponents raised to exponents, you multiply them. So that's x to the 6th. When you multiply, these two numbers are going to get multiplied first. So 4 times 6 is 24. And then x to the, now you're going to add the exponents, x to the 7th. And then when we divide, first we take care of the numbers. 20 goes into 80 4 times. And then I'm going to take the numerator, so I end up with 4, or the variables. And this is x to the 10 minus 12, which is really equal to x to the negative 2. Now, This negative exponent is the next rule you're going to learn. What in the world do I do with negative exponents? Well, you're not going to leave it as a negative exponent. That's another thing we don't want to do. So what do we do with negative exponents? Well, let's take a look at some things. What if I had 5 to the negative 1, or 5 to the negative 2, or 5 to the negative 3, or 5 to the negative 4? What would these be equivalent to? So in order to do that, I'm going to use my calculator. Hopefully I've got that up. So 5 raised to the, I don't know why I can't view my calculator. There it is. Negative 1 is equal to 1/5. So this is really equal to 1 over 5 to the positive 1. Let's take a look at 5 to the negative 2. Well, that's equal to 1 over 25, but isn't that really just 1 over 5 squared? All right, let's look at the next one. What about cubed? What about 5 to the negative 3? Well, that's equal to, I don't know if you saw it, 1 over 125, which is really equal to 1 over 5 to the positive 3. So look what's going on with these exponents. Negative 1 became positive 1 in the denominator. Negative 2 became positive 2 in the denominator. Negative 3 became positive 3 in the denominator. So if I'm a betting person, and I'm not really that much of a betting person, I would say this is equal to 1 over 5 to the positive 4, and it is true. When you have a variable or anything raised to a negative exponent, what happens is that will, I want you to think about this being over 1, that will go to the denominator and it will become positive. So this will become 1 over a to the positive m. What if I have something like this, 1 over a to the negative m down here? Well, if it's in the denominator and it has a negative exponent, oops. Well, I haven't had enough coffee apparently today. If it's in the denominator and we have a negative exponent, what's going to happen is it's going to come to the numerator and become positive. So what this will happen with this is this will become a to the positive m over 1. So again, if it's in the numerator and it's negative, it goes down. If it's in the denominator and it's a negative, it goes up. It has nothing to do with being negative. So x to the negative 1 is really 1 over x to the positive 1. Now I don't really need that positive 1, but that's okay. This one's a little bit tricky. This is really 3 times x to the negative 4. So this is the only thing being raised to the negative exponent, not the 3. So if I put this over 1, this thing is going to go to the denominator and become positive. I wonder if I can add pens. Oh, I can. I don't have enough examples. All right, cool. So now I got more. So what will happen is then this becomes, the 3 stays in the numerator. Why is it always picking these fat pens? 3 comes in the numerator, and then I get x to the positive 4. So it goes to the denominator, becomes positive. Now that, contrast that with this one. On this one, the whole thing is being raised to the negative exponent. So if I put this over 1, there we go again, big fat pen. I like those pens. This whole thing comes to the denominator. So what I end up with is 1 over, somebody's telling me to retire, I think, 3 to the positive 2. Well, that's really 1 over 9x squared. Now, where did the 9 come from? 3 squared, and then x squared. All right, let's deal with some examples. So again, I'm going to just put this over 1. So this has a negative exponent, and this has a negative exponent. And because of that, this is going to come down here, and this is going to come down here. What's going to stay in the numerator is the 5y squared. So x to the negative 3 goes to the denominator, becomes x to the positive 3. Yz to the negative 2 comes to the denominator, becomes yz to the positive 2. Now in this one, this whole entire thing is being raised to the negative exponent. So the whole thing is going to come down here and becomes 1 over 3m squared to the positive 3. Well, we really shouldn't leave it like that. That's 1 over 3, I said squared, but I meant cubed. 3 cubed is 27. M squared cubed. Now let's remember our old rules. Exponents raised to exponents. You multiply them and you get m to the positive 6. All right, I need to stop this for a minute. All right, sorry about that. Every once in a while I have to stop just to make sure my computer catches up. I need a new computer is what I need. All right, let's work on this one. All right, now, this one's a little weird. I'm going to add a new highlighter too. We'll go with blue. So, so this one has a negative exponent. And this one has a negative exponent. And this one has a negative exponent. So, this one, there's the big fat chubby bed. Stop. All right, this one is going to come up here. This one is going to come up here. And this one is going to go down here, really. So, these two are going to go up and combine with these three to make x to the 5th. Now, some people don't like that, but remember the rules of exponents say we subtract them. So this is really x cubed minus negative 2. Well, minus negative becomes 5, and there it is, x to the positive 5. Now, the z to the 4th just comes up. Now, let's deal with the y's. There were 2 on the top. Since they're going to go to the bottom, that leaves me y cubed. Now, why is that? Well, let's do with the math. Negative 2 minus 1. That's y to the negative 3. And guess, negative exponents make fractions. Have nothing to do with being negative. All right, now what do we do when we add and subtract? Now, I'm not going to spend a lot of time on adding, subtracting, because we got a whole chapter on that. But if I think about this, this is really 1 over x plus 1 over x to the positive 2. Again, they're both negative, so they both go to the denominator. Now, what we're going to learn out in a couple of days is when you have a common denominator, when you have adding and subtracting, you need to have a common denominator. So my common denominator actually would be x squared, which means I'm multiplying this times x to get that x squared. So I do that, I got to multiply the numerator by x, and I get x. Now this one, since this denominator didn't change, just stays 1. Now when you do that, your final answer is going to be keep the denominator and add the numerators, x plus 1. If you didn't fully understand that, I'm not that concerned. We're going to do that in a couple of days. All right, what am I going to do with this one? This one is just x over 1, so x over 1, nothing to change there, minus. Now, because this is negative, it's going to go to the denominator and become positive. 1 over x to the positive 1. So what's my common denominator? My common denominator is x. So this one got multiplied by x. That means this one has to get multiplied by x. So I end up with x squared. This one, nothing happened, so it's still 1. So my final answer for this one is x squared minus 1. And anytime we do something with adding and subtracting, we're going to end up putting in parentheses all over x. And we'll talk about that more later on. Now this one's a little strange. We're going to do a little bit with this one. This one goes up and becomes x squared over 1 plus this one goes down and becomes 1 over x squared. So my common denominator here really would be x to the x squared. This one doesn't change. But since this one got multiplied by x squared, this one gets multiplied by x squared, and I end up with x to the 4th. So my final answer for this one, and I'm not really cared about if you understand this, x to the 4th plus 1 over x squared. All right, let's do a few more examples. A few more weird ones. Just don't know what happened. That literally took me 2 minutes to find out where I moved to by accident. Okay, so let's take a look at each one of these. These things are a little bit weird. This thing is being raised to the negative exponent, and this thing is being raised to the negative exponent. So they're going to move, and that's what I want you to think about. These two are going to come down here. So what I end up with is, for these, I end up with y cubed. Now, here's how you want to deal with these exponents. Really what I have here is x to the 1 minus 2, which is really x to the negative 1. But that's kind of boring. That's kind of hard to do. So here's what I want you to think. Who has more x's, the top or the bottom? Clearly the bottom does. How many more? One more. So that's going to leave us x to the 1 here. And since nothing was left in the top, that's just 1. Now this is all being raised to the negative exponent, so this is really 1 over xy to the positive 1. But I don't really need the positive 1. I don't really need this. And I think I'm just going to leave that like that. I'm just going to rewrite these. Because other than that, I'm not really worried that you understand that. Let's just rewrite those. Now these are raised to the negative 2. So that's coming up here. So I end up with 3x squared. Since the only thing we raise to the negative exponent is this, that's going to come to the denominator, and that's going to be plus 5 over x. Now this one, since it's not too complicated, I might just show you how to finish this one. This is really 3 over x squared. Oops. Sorry. In order to add fractions, we need to have a common denominator. So my common denominator is just simply going to be x. So since this one's not changing, this one I had to multiply by x. So I got to multiply the numerator by x, so I get 3x cubed. We'll deal with this in a couple of days. Not a big deal. All right. So this has a negative exponent, so it's going to go down here, and it's going to become xy to the positive 2. Because there was already 1 down here, I'm just going to bring that down there. And again, the math is y to the negative 1 minus 1, which is really y to the negative 2, which means it's going to be in the denominator. So this whole thing is being raised to the negative 1 exponent. Not the 4. The 4 stays up here. And the denominator is xy squared, all raised to the positive 1, but I don't really need that. Now, if I was finishing this problem, this would just be negative 6 over xy squared. Why negative 6? Because negative 2 minus 4 is negative 6. All right, a couple practice problems. So this would be a typical test question. This one right here. Very simple question. First, we'll deal with the fraction. 3 goes into negative 9, negative 3 times. 3 goes into 4. 3 goes into 12 4 times. So the fraction I have here is 3/4. Now, who has these 3 x's are going to go down to the bottom. There's already 2 down there, so that's x to the 5. These 3 y's are going to go to the top. There's already 1 up there, so that's going to leave me y to the 4th. And then, well, the z's just cancel. And there's your answer. This one's a little bit trickier. Actually, it's quite a bit trickier. Since this whole thing is being raised to the negative exponent, this whole thing goes to the denominator. So there's nothing left in the numerator. So what I have here is 1 over, my hand keeps hitting this, 16xy negative 2x y squared to the positive 2. Now that we have to clean up. So let's deal with just this thing right here. This thing right here, since everything's being squared, is really positive 4 x squared y to the 4th. So my final answer for this one would be 1 over 64. That's the 16 times the 4. X here and x squared makes x cubed. Y and y to the 4th make y to the 5th. Again, we'll keep playing around with this as we go through the units so that it'll start to make more sense, hopefully, for most of you. All right. Goes down here. Becomes 1 over x squared plus. Now, the only thing being raised as a negative exponent on this one is this, and this is going to go down here, so this becomes 3 over x. And I'll combine those some other day. All right, let's deal with this one. 5 goes in here twice. 5 goes in here 3 times. So I know my fraction is 3 halves. Now, these 3 go up, and they combine with that one to make 4. Now, this is a weird one. These y's are going to go up. These y's are going to go down. So I'm just going to write that. y2, y1. Same thing's happening to the z's. These are going up. These are going down. So z to the 4th up here. Z cubed down here. Now I should finish this problem up. Who has more y's? The x, the top, or the bottom? The top does. How many more? 1. So that leaves me y up there. Who has more z's? The top. How many more? 1. Leaves me 1 z up top. So when it's just a single fraction like that, it's generally not very difficult. It's when it's all this adding and subtracting stuff. And again, we're going to deal with the adding and subtracting stuff later. I'll finish this problem up. Since this is being raised as a negative exponent, it goes to the bottom. So this really becomes negative 10 over x cubed minus 5 over x. Now my common denominator is going to be, if I look at these denominators, x cubed. So that means I have to multiply this by x squared, so I have to multiply this by x squared. So x cubed in the denominator, and my numerator becomes just this. Negative 10 minus 5x squared. Kind of boring. This one's crazy. So this is going to be 1 over 2w cubed minus 1 over 3w squared plus 3 over w. So this is really 1 over 8w cubed minus 1 over 9w squared plus 3 over w. Now if I look at these 3 denominators and I want to find the common denominator between that, and that, believe it or not, if you give yourself a second or pause it, you might be able to figure it out. Believe it or not, the common denominator is 72w cubed. 72w cubed. 72w cubed. Because that one's, I have to have a w cubed because that one has a w cubed. And the common denominator between 9 and 8 is 72. So that means I multiply this one just by 9. So this is 9. This one I multiply by 8w. So this is 8w. And this one I had to multiply, believe it or not, times 72w squared. So this gives me 216w squared. So the final answer for this crazy, stupid question is... Jeez. 9 plus 8w. Wait, one of those was a minus, I thought. Oh, this is a minus. And then plus 216w squared. Not that concerned that you know how to do that one. I'm not really concerned. These are the ones that are going to be typical. These two are going to be the typical ones. All right, that's it.